This is the most powerful feature you can add to your application this year. By the end of this video, I'm gonna show you how to build a bridge between your production data and a large language model. And the best part is, it only takes a few lines of Python code with FastAPI. This will let you turn any API endpoint into a tool that AI assistants like Claude can use to give you real-time answers about your business. Let's start by discussing the architecture design for our application. Basically, the KPI, the key performance indicator dashboard, is going to be talking to the LLM models through the Claude. Claude is going to be integrated well with the FastAPI. So whenever, as a founder, if I go and type in the Claude application, it will go to the FastAPI server through the MCP server and talk to my database and give me the real-time data response. So how does that work? Well, this application comes with two different components. First is the metrics, the second is the reporting aspect of it. Metrics comes with what are the key parameters or the indicators that the founders are really looking into in a dashboard or the KPI section. But the reporting part is basically a visualization aspect of it. That will come in a later video, but for now we are focusing on the metrics, connecting with the FastAPI server and the MCP server. Because this is a cool application and it can also be a standalone app by itself, I'm gonna create a beginner-friendly standalone app for the first time, and then in the next step I'm going to integrate that with the GPK application so that you have better understanding of how it looks as a standalone application, and when it comes to integration with a Docker-based application, how that is going to be like. For this project, we're going to use UV, which is a fast Python package and project manager. For Mac and Linux users, please go through this documentation and follow the instruction here to install the UV if you have not done already. And for Windows users, please follow this guideline here. Let's start a new terminal and then let's create a new directory for our project. Okay, I'm going to do UV init. Let's call it KPI. As you can see here, the project has been initialized at this location and there's a new folder coming up here. It generated all the files that are needed for our project. Okay, the next step is let's go inside this KPI folder, right? We are in here. Let's create a virtual environment for our project. So let's do UV, venv, and it does create a new virtual environment. You can see here there's a new folder .venv. Now let's activate that with this command source venv bin activate. So with that, now let's install the dependencies for our project. So let's do uv add mcp cli and sutpx. Okay, let's install that. We can see that the main file has been created. This is where we are going to write our MCP server, but we also need a FastAPI server. How do you do that? Let's create a new file called api.py. Okay, and here we need to write our FastAPI. So let's write our FastAPI. From FastAPI, import FastAPI. We need to do uv pip install FastAPI. It did add the package here. Let's call app equals FastAPI. Let's create an instance of our application. And here we are going to write a API endpoint. So let's call it app.get/KPI. And this is a simple function. Get KPI data is our function name, returns a sample data. All right, let's start a new terminal and run the FastAPI separately. Go here and then do uv curl API app reload. Okay, you can see it's running in port 8000. Okay, if you go to this localhost port 8000/docs, it will give us the API that we just created. Let's click on try it now. Let's hit enter. It does return the empty response. That's fine. That's what we expect. So now that we tested our simple FastAPI, let's customize the FastAPI to tailor to our application. This section initializes a FastAPI application with the title, description, and the version. This is where we add our course origin. It enables cross-origin resource sharing by allowing the request from any domain, which is helpful when the front end and back end are hosted on different domains. The sample KPI data is a mock data that we get from a database. Metrics contains all the metrics that we are interested or pulling from the database. You can see here the monthly recurring revenue. This is a sample monthly recurring revenue. And there are active users. It tells us what are the unique users who are engaged with our product. The churn rate is basically a percentage of the customers who stopped using the service. The customer acquisition cost is about the average cost to acquire a new customer. Lifetime value is the predicted revenue from a customer relationship. This is the metrics for our case. Okay, this is basically I'm mocking the sample response from a database, but we can get it from our database directly. Okay, I'm trying to keep things simple here. The root endpoint returns a welcome message and documents available endpoints. The health check API endpoint simply returns the status of the server and the current timestamp. This is very helpful if we want to check for the uptime monitoring. And this is our endpoint for KPIs. It returns all the KPI data in the sample KPI data dictionary. Get specific metric endpoint fetches data for one specific KPI, for example, KPI for active users. If the KPI does not exist, it returns 404. And this is our Business Insights API. Basically, the idea here is to programmatically analyze KPIs and return business insights like revenue is increasing month over month or not, and churn rate is decreasing, customer retention is improving or not, things like that. Let's restart our server and see if things are working fine or not. Okay, so this is our new API. You can refresh as well. Startup KPI dashboard API. If you click on routes, yeah, it should give us the metrics, all the data that we have defined. This is cool. Now let's go and check for the health check. Yeah, it's healthy. Now let's go to get all KPI data. Simply it's returning the sample data that we created, so not a problem at all. So now that we have a FastAPI up and running, let's create an MCP server for us. So let's start a new terminal. You can do that by clicking this button, new terminal. Let's go to KPI. Now we are finally ready to write our MCP server. Click on this main.py file. In here, first start by configuring our logging mechanism. Let's import logging. Now that we have logging set up for that, now let's configure our constants. We saw earlier that our API was available at localhost 8000. Either you can do 127.0.0.1 or localhost. It does not matter. It's the same thing. Now the MCP server name is defined as startup KPI server. Then now let's initialize our MCP server here. So initialize fast MCP server. So how do you do that? MCP equals fast MCP, and then the server name is going to be MCP server name. Okay, now we need to import MCP from mcp.server.fastMCP. You can import a FastMCP. From mcp.types, you can import tools like this. Let's create a helper functions. Let's create a new file for that. Let's call it helpers.py. Okay, and these helpers will contain the helper functions that is used in MCP server. Let's review the helpers.py file and let's try to understand what's going on here. The first function, fetch KPI data async. The purpose of this function is to fetch KPI data asynchronously from our FastAPI backend. How does it work? Well, it uses HTTPX async client to make a non-blocking HTTP GET request to /KPI. It uses HTTPX.async client to make a non-blocking HTTP GET request to /KPI. And if it is successful, it returns JSON data as a response. If it is not successful, if there's any exception, we are taking care of that appropriately. Now let's look at our second helper function called fetch KPI data sync. The purpose of this helper function is to fetch KPI data synchronously, which is a standard blocking HTTP request. Remember, this is a fetch KPI data synchronously, but this is asynchronously. And this function is going to be called from our FastAPI endpoint. But if we want some synchronous request, we can use this function. It's basically the same thing, just the synchronous or asynchronous approach. Okay, let's look at our another helper function, calculate growth rate. Well, the purpose of this helper function is to calculate the percentage growth between the first and the last data points. See here, this is a formula. It's using the last value minus first value divided by the first value times 100. Basically a straightforward growth rate calculation. Okay, let's look at our another helper function called analyze KPI trends. Purpose of this helper function is to analyze trends in the KPI data that we are going to use in the FastAPI. If you recall our database sample, here we have some data. We don't know how the data looks as of now, right? But then we want to have some insight into our data to understand what's going on with our startup product market fit, right? We want to understand how the monthly recurring revenue is growing or slowing down, right? So those things are taken care in this function. This function analyzes the trends in the KPI data and generates human readable insights. Nice to have a JSON data, but it's not always human readable. So for that purpose, we are going to parse the response into the human readable format like this. How does it work? It loops through all metrics in the KPI data. KPI data is simply the sample KPI data, right? And for each data, it calculates the growth rate. It checks the least value or the latest value. It checks the latest value. Then it generates insight messages depending on the type of the metrics, right? We are checking if the metrics type is certain metrics. We're checking for the metrics type. And if the match is found, we're checking the growth rate and the message is tailored accordingly. Well, just to summarize, fetches KPI data from /KPI asynchronously. The fetch KPI data synchronous is same as above, but blocking, meaning it's synchronous. The calculate growth rate function computes the percentage change between the first and the last data point. The analyze KPI trends generates natural language business insights. Now we have our helper functions created. Let's go ahead and write our tools. So let's go to main.py file to make sure that we have imported the helper functions from our helpers.py file and other dependencies. We can now implement the MCP tools. Let's break down the MCP tool. Well, the purpose of this is to fetch all the KPI metrics from /KPI endpoint. If you look at this function or the tool, it internally calls KPI data sync function, and this function is actually being called from the API endpoint. Okay, now let's look at our MCP tools. First one is fetch startup KPIs. The purpose of this tool is to fetch all KPI metrics from /KPI endpoint. If the fetch fails, for example, if the API is down, it returns the fallback as the sample data. Otherwise, it returns status, full KPI data, and the timestamp. This is particularly useful as a baseline feature for dashboard for AI assistants to pull metrics in one go. Simply, if you look at this tool, it is calling fetch KPI data sync function, which is defined in the helpers.py file, but this function internally calls our FastAPI endpoint. If you look at this line number 26, it calls /KPI endpoint, which is defined here, the API.py, and it is basically returning our sample KPI data. So in other words, this tool is simply fetching the sample KPI data directly. Let's go to our main function and try to integrate all of these together and call from our Claude desktop. Let's import UVcorn just like that. Now we can finally write a function, write a main execution function to serve the FastAPI server. And then I'm going to write a function to run MCP server. Let's write few configuration functions to run our integrated server. We have a main function. This is simply a print messages that is going to be displayed in the terminal for user notification. It is simply calling another function called run MCP server. These are all the print messages. Main function is calling the run MCP server internally. If you look at this run MCP server function, it's calling mcp.run. And this function mcp.run is actually running our MCP server. Okay, and then how do we tie these up together? Well, after this main, we need to do mcp.run and then use transport method equals stdio. Now let's try to integrate everything that we have built so far and test run what we have. We are going to run this file, the main.py file. If we go to terminal and just do python main.py, if it works, everything should be fine. If not, it will throw us the error. Says Python not found. So we need to migrate this helpers file inside the KPI folder. Let's create another file to store the constants.py. And in here, I will simply migrate this to constants file. Okay, and now we can do from constant import MCP server name. We can import this, and also in the helpers, we can also migrate this to constant file, then do logger, and in the constant files we can also do logger, import logger from constants. Okay, so now things are organized. Let's try to run again. Name logging is not defined. Did you forget to import logging here? And we need to import logging. KPI.main API file. Let's go here and we need to do from main import logger. It's supposed to be from constants import logger. Okay, let's rerun again. There we go. So we have our server running. Just to recap what we did so far, we restructured our files. We moved our helpers file. Make sure all the files that we created are inside this folder itself, such as api.py, constants.py, helpers.py, and main.py. Okay, before we go and integrate our Claude desktop, let me recap one more time. So let's start with our main.py file. So basically, what this file does is it initializes the MCP server, right? We have our MCP tool defined here, MCP tool 1, tool 2, and this is our fourth tool, right? So we have 4 different MCP tools. After we define the tool, we have some configuration for our main function to execute. Remember, our MCP server is calling our FastAPI at the runtime. So we need to ensure that whenever we are triggering our MCP server, it's also triggering the FastAPI run, right? This is what that does, run FastAPI server. And if you recall, this is not imported. App is coming from here, the api.py file. So how do we fix that? Extend this line and just add app here. Go down below and see this is now recognized as our app, uvcorn.config, and it's configuring our app run. Where is it hosted, port number, and things like that. Okay, so this function is now being called from this run MCP server wrapper function. This is simply running mcp.run, and main is finally triggering that run MCP server. So if you prefer, we can just get rid of that and just migrate here itself. Not a big deal. Okay, rerun one more time before you go and integrate our Claude desktop. Let's do python main.py. You see MCP is running. The FastAPI will be available here. Okay, after you download and install Claude for desktop, this is what you see. Right, so let's go to bottom left, click on settings, click on developer. Right now we have not integrated Claude desktop with our local MCP server. So for that, let's click on edit config. That should open our Claude desktop config file just like that. And here we need to configure our local server. I'm using a template here, so just paste it. So the MCP server name goes here. So in our case, that would be, what is our name of the server? MCP server name. Let's go here. Let's find that. Server name is startup KPI server, right? Replace this. MCP server is written in main.py file here. Okay, so let's use main.py. And now we need to do two things. So first is the command, the UV binaries. We need to figure out where the binaries are installed. So let's go to terminal. Let's execute that one more time, clear it, and type which UV. So it's gonna give you the location or the path where the binaries are available for UV based in the command. Great. Now we need to pass the argument, where is our MCP server implemented. So for that, again, go here to the root directory and copy the path. Now paste the whole path, absolute path in the directory, save everything, restart Claude for desktop. There we go. If you click on this button, you can see startup KPI server is available here for us to use as a tool. That's great. That's genius actually. And here we see that we have the tools that we created: fetch startup KPIs, get metrics and analysis, generate business insights, and compare metrics. Now we are ready to test it. On the left, I have this sample KPI data, and now we can actually use the Claude desktop to ask the question. So for example, I'm gonna say, what was my monthly recurring revenue for this month? What is my monthly recurring for, okay? I'm asking this question, so it should automatically detect that this question can be answered using our custom MCP server. Okay, let's see what it says. It should give us a pop-up. There we go. So it is recognizing that we're asking from our database or the local APIs. Now click on allow, and if it gives us this value, we can confirm this is working. Look at that. It says your monthly recurring revenue for August 2025 is 12,500. Great. This is a modest 2% increase from July's MRR of 12,250. Look at that. It's actually reading the data. It's also giving us some insight about what is happening with our data. Isn't that crazy? Now we can also extend this and ask questions like, now let me try to ask some thoughtful questions like, what can I do to improve, right? Now I'm asking questions that requires reasoning other than just factual data from the API itself. So it should actually call our API. What's the API? That should be our insight. See here, get business insights. And look at that. It's actually going to generate business insights tool in the main MCP tool, which is generate business insights. Let's click here. And it is also comparing the metrics. And see, based on your KPI analysis, you're actually performing quite well across most metrics. And it is giving me all the information that I need. This is genius. This is how we can use the FastAPI integrated with MCP to ask questions directly to the large language model and get some insight out of it. So see, basically we just created AI agent data analyst. Thank you so much for watching. If you like this video, please consider subscribing. It helps the channel a lot, and I'll see you guys next time. And if you guys are new here in the channel, please consider checking out the AI Engineer Bootcamp course, where you will learn from basics to mastering AI.